Hello, in this video I will show the capabilities of niliBOX to handle SDR receivers. I will be using niliBOX for Windows, but all the functionalities that I will show here are also available in all the other operating systems that are supported, with the exception of iOS, which cannot handle USB devices. niliBOX supports two types of SDR receivers: the USB dongles based on the Realtek chip RTL 2832U, and the receiver RSP1A from SDRplay. First of all, I will show the hardware configuration that I will use for this video. In my computer, I have connected a USB hub where I have connected this USB cable, which is connected to an SDRplay RSP1A receiver, and also this SDR dongle of brand Noelec, which is also connected to an antenna. I will show how these two devices are seen by niliBOX. To do this, I will use the driver test module, where you can see the hardware configuration. Here you can see the Realtek device with its USB ID, and also the SDRplay device also with its corresponding USB ID. So let's go now to load and configure the corresponding modules. I will go to the settings module, devices section, and click on add a new device. I will select first the module for the Realtek receiver. Press here, and you can see that the SDR dongle has been recognized. It is showing here the USB ID and the description. I will just add a name here. I will call it RTL SDR. And we are done with the configuration. Now I will proceed with the configuration of the SDRplay receiver. To do that, I will use this module here, SDRplay RSP1A. And it works very similar to the previous one. You can see here that the receiver has been recognized. You can see the serial number of the receiver and the model. As before, I will give it a name. I will call it simply RSP1A. And we are done. We can close and save the configuration. I also want to show what happens if we connect more than one device of the same type. I will open again the RTL SDR module, and I will connect a second SDR dongle like this one. It is another type, but the USB ID will be the same. So I will connect it, and you will see that the previous one has disappeared. Why is this happening this? It is because as there are two devices with the same USB ID, niliBOX is adding this suffix here, which is a consecutive number. If I select number 0, I will be selecting the same one as before, but I also have number 1 for the new one. It is important to notice that the USB ID will change if you have one or more than one device. If I now remove the second one that I connected, you will see that it has lost the suffix 0. So this is important if you make a configuration with only one and then you try to use it with more than one connected. Now let's do the same with the other module for SDRplay. I will open the module. We still have one device connected, but now I will connect this USB cable, which is connected to another RSP1A device. I will connect it here. And after a few seconds, we can see that a new device appears. In this case, it works different than with the SDR dongles because the devices are identified by their serial number. So there is no confusion. If you have this one already selected and I disconnect the other one, it will not change. That will not happen. If I connect it again, I select the second one, and now I disconnect it. It will be removed, and the serial number that will appear is the one for the first one that I connected. If your computer is not recognizing these devices, you can try to install the WinUSB driver using the software Zadig that you have the link here. Both for SDRplay and for SDR dongles. In the case of SDRplay, you can also install the driver that comes with the software from SDRplay. And now we are ready to start using these modules. I will save again, close configuration, and you will see that two new modules have appeared here, RSP1A and RTL SDR, the name that I gave to these modules. To show the general functionalities of an SDR module, I will use this one here, RTL SDR. The functionalities are more or less the same as for SP1 with certain differences, so I will show the main functionalities with this one, which is the most common, and later on I will explain the differences for RSP1A receivers. I will open now. Here you can see the type of module. This shows that this is the module for Realtek with this chipset, and you can also see here the type of SDR dongle that has been detected, what kind of tuner it is implementing. In this case, this dongle that I'm using is implementing the Elonix E4000 tuner. And now I will proceed to describe each one of the controls available in this interface. The first one that you will notice is the power button to start using the receiver. If it shows green, it means that the device, the dongle, has been recognized. If I now remove the dongle, it will turn red, so it is not available. If I put it back, then it will go green again. When the receiver is power on, then this button will turn blue. Now there is nothing tuned, so we just get noise. The next section to the right is the audio section, the audio output section. Here you can select what audio output you will use to listen to the receiver. You can select between all the ones that are available, and also a virtual device null, which means no output. If I select this, there will be no output. Let me show you this. You can hear the audio going out. If I select null, then there is no audio. You can still continue using everything, but there will be no sound. And here you can also select other outputs. I will mute it so that you can hear me. The next button is the audio settings. Here you can select the sampling frequency for the output audio. You can go from 8 kHz to 48 kHz, and the default is 32 kHz. Here you can select the sampling bits, 8 bits, 16 bits, and 32 bit. The default is 32 bit, which is the one that I recommend if you are using niliBOX in a local computer. If you are using it remotely, you could benefit of using lower sampling bits, because then the network usage will be lower. And here the audio compression. If you are at 32-bit, you can select compress the audio before it is sent to a remote device, usually, to 16-bit or 8-bit. The same, if you have 16-bit, you can also compress to 8 bits, and if you are at 8 bits, there's nothing to compress. And finally, we have the output gain. Now I will make a little parenthesis to explain how the output gains work, and for that I will use this simple diagram. When you are using niliBOX with an SDR receiver, there are 3 different audio gains that you can control, and they are marked here. Here you can see a schematic representation. You have an SDR receiver, could be an SDR dongle or an SDRplay receiver, getting signal. This signal is transferred in digital mode to the SDR module inside the application niliBOX. So here you have your PC in blue, the niliBOX application in orange, and the SDR module inside the application niliBOX in green. The first gain that you can select is this one here, which is the output of the SDR. This is equivalent to the gain of the receiver itself. This volume number 1 is this one here, AF gain, that you can see. This is the gain of the receiver. Then you have the output gain of the application itself, of niliBOX, of this module of niliBOX. And this is the audio gain that you can select in this one here. Finally, you have the third audio gain, which is the output gain of the PC itself. And this is the gain that you can control with the normal gain controls of your computer, depending on the operating system that you are using. My recommendation is that you set your normal volume on your computer. You let the gain of the niliBOX itself at maximum, which is the default, and then you control the audio gain with this control here. But you could also select the gain here. You can see that if I increase this and I decrease here, that the gain also goes out. To the right of the audio control, we have the visualization controls. Here we can select what we want to see on top of the default configuration. We have buttons to see the band scope of the signal that is being received, to see the band spectrogram related to this band scope. We can also see the audio signal in time, the audio signal in frequency, the spectrogram of the audio signal in frequency too, and finally the tools section that we will cover later. We will go through all these different visualization panels later. Now I will remove all them except this one so that we can see what we are doing. I will also remove the diagram. And now we will continue explaining all these controls here. This control here, this knob, is to control the tuning frequency. This type of control, the knob, appears in many places in niliBOX. So I will stop here to explain how it works. There are a few ways to use it. You can simply click on it and turn it right or left. You can also use your mouse wheel to control it. Now I'm using my mouse wheel and you see that the effect is the same. And also you can double click on it and then you change to a different mode where you can simply click on it and turn to the right, go to the right or to the left for a fastest change of frequency. You can see. Okay. Below the tuning frequency control, you can find the typical band selectors that you can find on any radio receiver. You have AM, FM, wide FM, lower sideband, upper sideband, and double sideband. I will stay for the time being in AM. I haven't mentioned that there are two other ways to select the frequency. You can simply type on your keyboard a frequency like this, where the dot is the separator for megahertz, and when you press enter, you simply move to this new station. Also, if you are on a mobile device and you don't have a keyboard, you can simply click on the frequency and this virtual keyboard will appear. Here you can select any frequency and press enter, and then you can press anywhere to hide this keyboard. Next, we have the sampling frequency control. This is especially for SDR receivers, where you can control the sampling frequency. In the case of the SDR dongles, you can go from as low as 225 kilohertz to as high as 2.8 megahertz. You can see that when I decrease the sampling frequency, the band scope becomes wider, which is normal behavior in these cases. I will leave it in 2 megahertz, which is the one that I recommend. Then this is the demodulation filter. To show this, I will move to a station that we can see more clearly. This is a little FM station that I have created at home to avoid copyright issues with the commercial stations. I will put the the sound, WFM,
Så han sendte den til mekaniker, han sendte den til
and
reparation,
here I
til
want to
efterstaden,
show
så den skulle
how
virke
works
igen.
the demodulation
Men altså, man
filter. You
spille
can
på
see
den,
this
rent
little square
faktisk.
here,
Og det kan man så også
rectangle,
på de
in a
16
different
andre
color,
elektriske
which
guitarer, der er også
shows
salg på den her
how wide
option, der
is
hedder Prop Store
this
Option.
filter.
Det er i
If I
næste
increase
måned.
it, usually for FM stations, it is between 200 to 120 kilohertz. I will leave it at 200. Now you can see that the station is well demodulated.
Ja, lige præcis. Den guitar, der blev brugt til at indspille kæmpe hittet Wonderwall,
Okay.
er også på.
Next, we have the RF gain of the SDR dongle. You can change the gain. You can see how the strength of the signal increases when I go to 42 dBs, which is the maximum in this case. Also the noise increases, of course. And the last two controls in this section is the automatic gate control for audio. This one, you can see that it changes the gain, and also the gain control, the automatic gate control for the RTL receiver itself, for the SDR dongle. You can see how the gain changes. I will put the RF gain to auto again, and now I will move finally to this area here, which are the typical controls that we have in any radio receiver. We have already used the audio gain, this one. This is mute.
Der er nye guitar.
This is a squelch. Let me show you. Let's put some noise. If I increase the squelch, then at a certain point, the noise will be cut. This is the typical squelch of any radio receiver. If you click here, then it is monitored and the squelch is deactivated. The next control is PPM, which is used to apply a very small shift in the tuning frequency, parts per million. This is a very small one, but if your receiver is not well calibrated, you can use this control to adjust the tuning frequency. It can go positive or negative. And with this button here, you center to 0 again. The next one is the typical frequency step. When I change the frequency here, it applies the step that is established. Right now, it is 100 kilohertz. And we can change here the step. If I put it at 10 kilohertz, for instance, now it will change by 10 kilohertz. This is typical behavior in any radio receiver. There are many steps that you can select, from 1 hertz to 10 megahertz of a step. This is quite big. I will put it back to something like 100 kilohertz. With this button here, you can define what steps do you want to be available. If there are certain steps that you never used, that you want to remove from this control here, then you can simply delete them, or you can also add your own steps. Then you click on enter and these steps will be applied. And finally, these two controls here are to set memories and banks of memories. In niliBOX, there are 1000 available banks, and each bank can contain up to 1000 memories. I have got many questions about these controls work. I understand that this is not very straightforward, but I will try to explain here the philosophy. Let's start with the memory. Let's imagine that you want to set one frequency in memory number 1. So the first step is to choose the memory that you want to set. If it is empty, at this moment it is empty, then click on set memory. You type a name for this memory, memory 1, and click on enter. And now you see that the name appears here. And now you can close here. If you want to unset a memory, then you go to the memory and click on this one, delete. And now it is unset. I will move to, okay, let's create this one again, set. And now if I want to create another memory, I select the bank, for instance, the memory. I select the memory 0. I change to another frequency. This one, for instance, I change to, let's say, AM, just to provide an example. And now I set the memory. For instance, memory 2, memory 0, better. I set it. And now I have two memories, 0 and 1. If you want to set another memory, then you need to move to one empty memory. The same is more or less with the banks. A bank is a set of memories, so you can set bank 0 to something like we want to set here the FM stations. And now the bank 0 is for FM stations. Still, the memories are there. If you change to a different bank, then the memories are not there because we are in a different bank. Here you can delete the name of a bank, but if you do this, you are not deleting the memories stored in this bank. The memories are still there. The only thing that we have deleted is the name of the bank. If you want to erase all the memories in this bank, then you need to select this button here. I will do it now. It takes some time because it is erasing the 1000 memories inside. And now you can see that the memories that I set earlier are no longer there. So this is how the memories and the banks work. I want to insist that I have had a few questions about this. I understand that they are not straightforward. Maybe in new versions of niliBOX I will change this behavior. And now let's move to the visualization panels. I will put the step to 100 kilohertz and WFM. I will tune to my frequency and we can see that the sound is there. So now I will explain this panel here, the band scope. There are a few things that we can do here. First of all, we can graphically set a tuning frequency here. If I click on any place, you can see that the frequency is shown here where the mouse is located. If I want to change to this frequency here, simply click on it and it will be tuned. If I click on this frequency here, you see that it moves to that frequency. You can also simply drag the band scope to find other stations. This is a good way to simply scan a certain area of frequencies. You see, they appear there. I don't have good reception in this tuner right now because the antenna is a very small one. I'm using a whip antenna at home. Okay, let's move again to my frequency. Then we have this control here for delay. Here you can control how often the band scope is refreshed. When you are working in remote operation, this could be useful to reduce the usage of network bandwidth. Now I will leave it at 0, which is the maximum. Then we have these controls here. Here we can control how the band scope behaves. You can set the offset, so the minimum gain, the one here. You can also change the reference, so the maximum that is shown here. I recommend to leave this always at 0 dB, but this one, depending on the level of noise that you have, could be useful to change. Then you can zoom the band scope. I will do this and you can see that it becomes wider. This can also be done by simply reducing the sampling frequency. But if you don't want to do that, but you want to see the spectrum wider, then you can apply this zoom. This zoom consumes a big amount of CPU and bandwidth, so I don't recommend it unless you really need it. And this one here is the quality of the FFT, so how many points are used to create the band scope representation. You can go up to 128 kilosamples. I like this one 32 because it is like a compromise between CPU consumption and bandwidth and quality of the graphics. And finally, this button here is to make it bigger or smaller. This is useful if you are in maximized mode. I will go now to maximize. You can see how you can change how the band scope looks. The next visualization panel is the band spectrogram. The same as with the band scope, you can select the delay, so the refresh rate. You can see that when I put it at 0, it moves faster than if I put it in a higher value. And the same as in band scope, you can also change the height of this graph. The other visualization panels are for the audio output. You can see here the audio in time, in frequency, and in spectrogram. When the application is maximized, if there is enough space in horizontal, then these three panels, they align in horizontal. If we put it in the original size, then they are one below the other. I recommend this one with SDR receivers. In the time panel, there is nothing to control. In the spectrogram, you can also select the delay, so how fast it goes down. And here, in the frequency, there are a few other things that we can do. We can filter the audio output. I will select filter, and now imagine that you want to remove this little peak here. You just move the band,
som støtter demokratisk udvikling i forskellige lande,
and it is removed.
Skal nu efterforskes.
You can play with it if you need to remove or filter in some way. You can see how it has changed now, and you can apply a pass filter in this region or a reject filter. In the case of reject, for instance, could be useful to remove, for instance, this frequency there. We are just rejecting this little band here. This could be useful if you have noise or if you have some other kind of interferences. Okay, I will mute now again. And finally, I will show the tools panel. I will make this a bit smaller so that we can see it completely. This panel here has different sections. The first one is for filtering. Here you have the de-emphasis section for broadcasting stations in FM. You know that the commercial radio stations, they apply an emphasis filter or gain, and here you can select the emphasis. You can select off. I will put some sound now. This is without the emphasis. This is the emphasis at 15 microseconds, which is the standard for Europe, and this is 75 microseconds, which is the standard for the Americas. You can also select no filter at all to the audio output with this one. It is difficult to see the difference. You can see that there is much more noise here than if I select filter. The next section is for noise reduction. In the FM band, it is difficult to see the result. I will try to show something. I will just click here on a noisy part of the spectrum. I will remove the squelch. And now we have some noise. If I apply noise reduction, you can see that it is reduced. This is more evident if you are in a shortwave station with some white noise. Then this could be very useful. I will move back to my station. And this section here is to record. You can either record audio, the audio output, or you can also record the raw signal. That means the digital signal IQ signals that come from the SDR dongle. I will first show how to record purely audio. You can see that it is creating a file which contains in the name the date, the time, the frequency, and the band. You can see the size that it is increasing here and the time that it is recorded. And now I will stop. The files available are shown by clicking on this, on the file name. If I record a second one and stop it, now we have two different files here. I will remove something here so that we can see it better. You see the two files that we have recorded. We can also record the raw signal. To do this, press on raw and press record. You will see that the size of the file is much bigger. Careful with this. It also depends on the sampling frequency that you are using. And you will notice that it also appears in this area here. And I will explain now what is the reason for that. The raw signal that we have recorded can also be used to play again in the same receiver. Let me show you. I will move to a frequency without any signal. And now I will press play from raw. From where? From this file that we just recorded in raw. So I will press here. And you will see that it is showing the frequency that we have recorded before. As this is raw signal, you can even change the filter, you can change the band, because what we are reproducing is the raw signal that was coming from the dongle. It is different than when we record the audio. When you record audio and you reproduce that audio using some other module from niliBOX, then you will not be able to change filter or band or gain or anything like that. If I now unselect play from raw, we will move back to the frequency that we have selected, and now we are working in normal mode, let's say. And with this we have completed going through all the different controls that you can use in an SDR receiver. This is for the SDR dongles. We have used a Lonix EF4000 tuner, and now we will go through the same module but for SDRplay receivers, and we will see what are the differences. I will stop here, close, and open RSP1A. Here it is. You can see that the user interface is almost identical. All this upper panel is the same. This area here is also the same. The tuning frequency and the bands are also the same. Here, in this area here to the right, is where we may have some differences. I will open the band scope, and to demonstrate how it works with this receiver, I will use a shortwave. I will see if I can tune something around. I don't have good reception in this where I'm placed here, but yes, you can hear some shortwave. I will reduce the demodulation filter to, let's say, 20 kilohertz. And now I will show you some functionalities here. First, the sampling frequency. It is the same concept as with the SDR dongles, but the range of frequencies is completely different. In the case of SDRplay, you can go up to 12 megahertz. You can go from very low ones to something in the area of several megahertz. I don't recommend going so high. I like, in my case, 6 megahertz is like a good one. Then we have the demodulation filter, same as before, and we have the RF gain. You see how it goes up and down. Okay, for the case of shortwave, I will put it to something like 60 dBs. And this control here is the bandwidth, is the reception bandwidth. This is a concept on the SDRplay receivers. If I reduce it, then you can see that the bandwidth that is demodulated is lower. Usually I have it at maximum. Finally, we have the automatic gate control for the audio. You can see there. Let's try to tune something. Okay, I need to reduce the step to 5 kilohertz, for instance, and now I can move through the band.
The uncertainty coming from the US and also the uncertainty that is...
Okay, we can see it there, how it works. The last button here is BST, which is to apply power on the antenna cable. You should know what is this. Now let's play a little bit with these buttons here, with these controls here. You see that you can extend the FFT. Let's leave it in 64. You can zoom, which is very convenient if you want to tune using the band scope itself. You can see the filter that we are applying, which is 20 kilohertz. If I reduce the filter, it will reduce here. And what else? Let's see if I can find another one. Okay, this is noise. Yeah, let's move to this area here, which looks the more active one. And here I want to show you how it works. Let me see if I can tune something. Okay, this one I will. Let me show you with the tools how the noise reduction works. I will increase the audio gain so that you can hear it.
De la mobilisation refuse de baisser les bras et donne déjà rendez-vous le 1er novembre pour le premier anniversaire de la chute mortelle de l'auvent de la gare de Novi Sad, l'accident devenu le symbole de la dérive autoritaire d'Alexander Vučić. Belgrade, Simon Rico.
Is heavily reduced. If you continue reducing, then the voice itself will be distorted. But you see the difference between noise reduction and no noise reduction.
A fait part dans une note de la préoccupation des évêques européens envers les nombreux conflits qui déchirent la planète, à commencer par la bande de Gaza, l'Ukraine ou encore le Soudan. La Comice est située au cœur.
Now let's put this a bit more beautiful, like this. And you can see an SDRplay RSP1 fully functional in your screen. Finally, I want to show you some other alternatives. I will keep this running and I will show how you can use two receivers at the same time. This is what we were using before, and you can simply switch between one and the other. They are both. Okay, I will remove mute for a second.
Des délégations venues du monde entier convergent vers Rome car s'y ouvre demain un double jubilé, celui des migrants et personnes réfugiées et celui du monde missionnaire. Et à cette occasion, nous donnons ce soir la parole à un prêtre des missions étrangères qui a passé près de 30 ans à Madagascar dans un diocèse.
Okay, you can see that they are both running in parallel at the same time. You can also do this with two receivers of the same type. Depending on how powerful is your computer, you can do it even with more than two receivers. And finally, I will show you how to do this showing the two receivers at the same time. I will close here the RSP1A. I will leave this one. I will put it in, okay, I will put it in this area here. Let's see if I can do it. And I will open another one. I will try to place it like here. I have opened two instances of niliBOX, and each one of them can run a different receiver. You can see that RTL SDR is not available because it is in use here, but I can open the other one. And now we have the two receivers running and visible at the same time. And with this, I think that I have covered all the different functionalities. I hope that I haven't forgotten anything. Of course, if you have any doubt or question or comments, don't hesitate to leave me messages in this video or send me an email.